I hope you are enjoying your reInvent 2024. This is a session on modernizing and integrating ExxonMobil's ERP systems and apps with ROSA. I am Bala Chandrasekharan. I'm a principal product manager with Red Hat Cloud Services, and I focus on Red Hat OpenShift Service on AWS. So initially, I will just give an overview of what ROSA is and what common customer use cases are before we go into sharing the customer success story with ROSA. So Red Hat OpenShift Service on AWS, or ROSA in short, is a joint solution between AWS and Red Hat. We co-engineer, support, and design this service to provide a hybrid solution for containerized applications and virtualized applications and AI workloads that need to seamlessly run between private data centers on public clouds, on multiple public clouds. So the goal or the vision for this platform is to accelerate time to value so that you can bring all the developer workflows and security workflows together in a common platform and get the value as soon as possible. It's built to be operationally efficient so that you can do all the regular tasks using operators. It is also managed by a global SRE organization, so that it takes a lot of operational work that you would normally do in running an application platform. So what it lets you do is focus on your applications and focus on the innovation that matters to your business. As I said, because it gives a common set of APIs and workflows, you can seamlessly build and deploy applications between clouds and between operating environments. So how OpenShift is different from rest of the Kubernetes-based platforms is that OpenShift is a comprehensive application platform for modernization. So prior to this role, I used to be a platform product manager where I did a do-yourself Kubernetes-powered platform. Building all the components, integrating, upgrading the platform is an arduous task that does not end with just building the platform, but you have to continuously, repetitively maintain the platform over the lifetime. ROSA, on the other hand, is a turnkey application platform. You get security, observability, and all the development tools, all part of the platform. So this is an overview of AWS's portfolio for container services. You can see Red Hat OpenShift Service on AWS offers a turnkey application platform that integrates well and seamlessly with the rest of the AWS services like IAM, VPC, and others, but also provides you the flexibility to mix and match based on your needs. So as I said, like any Kubernetes-based platform, OpenShift offers you the flexibility to bring various of workloads while offering you a common set of tools that you can use to deploy and manage these different workloads across different use cases. So these are 4 common things I would like to highlight. The first one is application modernization and cloud-native development. Customers who want to move off and do container-based cloud-native development are adopting OpenShift. Virtualization allows customers to take their existing VMs, containerize them so that they can shift the workloads to cloud, but also convert the virtualized workloads to cloud-native workloads at their own pace. OpenShift AI runs as an add-on on top of OpenShift, provides you end-to-end ML operation toolkit and components. Customers and a lot of customers use commercial or commodity off-the-shelf software applications on OpenShift as well. So here is an overview of a journey a typical customer would take on modernizing their applications. First, they would probably have a legacy on-premise applications that are growing in footprint and costing them a lot. So using OpenShift virtualization, they migrate the VM workloads or existing workloads to a cloud environment that helps them reduce the cost, but also get them off of private data centers. The next stage, they would start identifying and categorizing applications that are suitable and required to go to cloud native deployment model. Then they would start migrating applications at their own pace. While doing so, they would use the same tools they've used on-prem, but also they would be using the same tooling and workflows across virtualized workloads and cloud native workloads. Here is an example of how customers use OpenShift AI and Watson X and other AWS services on top of OpenShift for their AI workloads. So OpenShift here offers components, for example, for model training, fine-tuning, serving, and also observing and monitoring models that they have trained and deployed in their environment. They could also use the end-to-end workflow for their ML workloads, but also mix and match depending upon what their needs are. If they have a data store that is on-prem, that is required to train the data with, they could use the OpenShift for on-prem to train their workloads, and then use the ROSA on cloud for serving traffic or serving inferences using the same components and same workflows. So thank you. I hope that gave you some overview about ROSA and what are some common ways you can modernize the workloads and migrate them to cloud. Now I would like to invite Chuck from ExxonMobil to share the customer success story he has with the ROSA. Over to you, Chuck.
Thank you. Thank you, Bala. Appreciate the introduction. I appreciate it was a very comprehensive overview that you just made, so great work. So I'm going to do a quick exercise here, a quick poll. How many of us in the audience work at an enterprise that is going through a modernization journey? And if from ExxonMobil, you were precluded from that poll. How many of us? Show of hands. All right, there you go. We do have quite a bit of people, quite a good number of people who are going through, whose enterprises are going through a modernization journey. If I follow up that question and I asked you what your modernization, what your platform looked like, what your IT landscape looked like before you began your modernization journey, you would say that it looked like this, right? You would tell me that it looked like a mess. It looked like a mess. It looked chaotic. It was a jumble of services, applications, processes that we had built up over time. We had customized over time, layered in millions of lines of code for customization. This is probably what your IT landscape looked like. This, just looking at this picture, kind of reminds me of Maria Kondo, who is very great at organization, right? Who has, an excellent skill set in tidying up mess. But if only we had Maria Kondo that would tidy up our IT landscape for us, right? Everything will be hunky-dory. Modernization is hard. Transformation is complex. These things are really, 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 really hard subjects for our enterprises to tackle. It takes a lot of money, it takes a lot of effort, it takes a lot of time to go through a successful journey where we change out our legacy systems, technical debt, And then we moved to microservices. We moved to cloud-based applications and services that are going to enhance our operations. But if I layer on one more complication to this already huge problem, that complication is that we need to do this. We need to straighten out this yarn. We need to isolate each of these yarn, the new applications we're bringing in, while still delivering value to our enterprise. Isn't that right? We can't just shut off our IT systems and start all over again. We need to be able to do it while we're still delivering value. Now, the problem is, the tendency is that we start to straighten out this yarn, we start to bring in new applications, new services into our ecosystem, but those applications and services, sometimes we don't integrate them. We don't integrate them with the rest of the stuff that we have in our toolkit, in our landscape, right? Integration is the essential ingredient that we need to modernize our platforms, to stitch together all of the best-of-breed products that we're bringing in to replace the legacy systems that we had in place. We need to be able to integrate the yarn that we have, that we just straightened out. We need to integrate it for us to be able to deliver end-to-end business value for our customers, our enterprises. Now, I'm just going to do a quick introduction. My name is Chukwuma Owanna. People tend to call me Chuck when they can't say my first name right. I am a technologist at heart. I am a self-taught Linux, high-performance computing, and containers expert. I am knowledgeable in on-premises and cloud-native tools and technologies. I began my IT journey at the National Institutes of Health, the NIH, where I joined as an HPC engineer, a high-performance computing engineer. I then went on to NASA and Boeing as a simulation engineer, as a training systems integration lab manager. I joined ExxonMobil as a high-performance computing specialist in our upstream division. At ExxonMobil, I've been privileged to be solution architect for our container platforms team. In fact, it was while I was on that platform as a solution architect that I designed and helped deploy the ROSA cluster, the ROSA clusters that I'm going to be talking about today. I do know where the bodies are buried. Where the containers are buried on that platform. And just don't tell anyone. I am currently a cloud optimization strategy advisor at ExxonMobil, and the pictures that you see to the bottom of your screen are me just having concluded a training session for astronauts on how to fly a space vehicle, and me in our Boeing engineering simulator at the time. The last picture is me at the HPC data center at ExxonMobil. I am married, I have 4 children, and just this past summer, something interesting happened. My 3 older children picked up crocheting. They started to crochet. I don't know how, but for any crochet enthusiasts in the audience, my children are kindred spirits of yours. And they would frequently, put out their yarn bundle, and the baby of the house would go pick up that yarn bundle and start to mess it up. So my responsibility was to untangle the yarn that my children were going to use to knit, to crochet. And it was while I was doing that I started to think about the problems that we're solving in our IT enterprises. It is really that. We're constantly untangling yarns. We're trying to straighten out yarn to make our platforms more efficient, more effective. That's what we do. So I credit my children for the inspiration behind the imagery that I'm going to use today. All right, so today we're going to weave. We're going to do a weave through ExxonMobil's ERP landscape, our enterprise resource planning systems, what they look like today, what is changing with our ERP landscape. We're going to talk about what else is changing as part of our modernization journey, our transformation journey, which has been a multi-year effort that is still ongoing today. going to talk about how we're doing this, how we're going through this transformation journey, and share some of the early wins that we have recorded along in this journey. I will also weave through how our ROSA platforms look, why we are succeeding in this modernization journey, and some of the things that I call enablement accelerators, things that are enabling our business, our teams to deliver value, speed to market. I will share some of the learnings that we've gotten from our ROSA deployments, and then I'll close with some thoughts. So, question: how does a 140-year-old energy company like ExxonMobil, as large as it is, with the size and complexity and the scale of our operations, how does a company this large go through a transformation journey, go through a modernization journey? How do we take our legacy enterprise resource planning systems, ERP systems that are largely based on premises, how do we modernize this to cloud-based ERP systems? How do we do this? This is a huge undertaking. It is really, really huge because, as I said earlier, we can't just dispense of the things that we had in the past and build something new. Our business has to run. But these systems are the bedrock of our operations. And to my AWS friends in the audience, no pun intended on bedrock. So these systems are the bedrock of our operations. This is how we deliver value. These are our upstream SAP systems, our downstream SAP systems, our human resources systems. These are the systems, our ERP systems that are responsible for us trading our commodities, right? For us to interact with our customers. These systems are huge, multi-million-dollar systems, multi-million-dollar operations that transact within these systems periodically. How do we go through an exercise like this? Well, that's what ExxonMobil is doing. And we're replacing those 10 ERP systems that you're looking at with 3. So we're not just modernizing and going to cloud-based ERP systems, we're also rationalizing our ERP systems. It makes the problem even more complicated, doesn't it? Right? We're going to an ERP system for molecule extraction, an ERP system for molecule management, and another one for centralized services. Really, really huge effort that we're undergoing right now. But the question becomes, how do we integrate these systems? What is the essential ingredient for making sure that we're building a solid foundation for our operations for the next 100 years? How do we do that? Well, ExxonMobil is integrating these ERP systems with a suite of tools, API tools that we call native API platform. It is a native API platform has a self-hosted API gateway and then reusable catalogs that we can use to host our APIs at scale. Now, I want to share a little bit about other things that are changing within our environment. We're not just modernizing our ERP systems and rationalizing them to 3. We're also simplifying the processes that we use to do work, making things easier for our employees, our customers. We're streamlining our data objects, right? About 700 data objects are getting streamlined as part of this exercise. These are our manufacturing data lake. These are our upstream data foundation. Things like that are getting simplified and streamlined during this exercise. We're also integrating about 500 applications in the ecosystem of our ERP systems. Now, think about that for a second. 500 apps and services are getting integrated through this journey. This is huge, very, very huge. Now, I mentioned Native API Platform as our reimagined API platform of the future. We're migrating about 300 APIs that we have today, largely on premises, to Native API. Another very, very complicated task. Complicated because some of these APIs handle billions of dollars worth of transactions a year. Very huge effort here. But where are we hosting the native API platform that we're going to migrate these APIs? The native API platform that is going to integrate our ERP systems and the suite of tools that come with them, that work with them. Where are we going to host this? ExxonMobil is hosting our ERP system, our native API platform on ROSA, Red Hat OpenShift Service on AWS. This particular ROSA instance is hosted in something that we call a managed AWS account, which is a hybrid cloud for all intents and purposes, a private cloud, right? That's where we're hosting ROSA for this particular use case. We're doing that because then we can have seamless integration between other on-premises applications and the internet. So today, ROSA is providing us with the scalability that we need for this, our reimagined integration and API management solution, the native API platform. It's already doing that. But it's not just doing that. So the native API platform is deployed on ROSA, and it's already integrating some of our ERP systems, those three that I mentioned earlier: molecule management, molecule extraction, centralized services. We're already using the native API platform hosted on ROSA to integrate those systems, as well as those systems with the suite of tools and applications in the ecosystem. APIs that we need for expense reporting for our trading organization and others are already being hosted on native API, but we're also running some other applications or services like other validation services on ROSA. So it's already in production. We're already using ROSA, not just for API hosting, right? But we're already using it to host our business critical applications like OpenText. In production, we're already using ROSA to host our image repository, our centralized image repository for all the enterprise called Key, right? We're using ROSA as well for OpenShift Dev Spaces, our cloud-based development environment for all of ExxonMobil IT. Our ROSA platform is not just a hosting platform for these tools and services that I just mentioned. It is also a platform for migration of other on-premises services that we have, other on-premises applications that we have. We're going to move them to our private cloud environment in managed AWS, and then we're going to modernize these applications there, right? So it's doing multiple duties for us. We recently completed a POC on OpenShift virtualization on bare metal servers, and we had some positive results on that. So we're all, ROSA is becoming a key foundational element for how we're going to compute, how ExxonMobil is going to compute in the future. Now, how are we doing this? How are we able to leverage ROSA for migration activities, for integrations of our ERP systems, for integration of the other tools and applications that are in the ecosystem of our ERP systems? How are we doing that? I really like this slide. I like this slide a lot. I like it because it's a very simplified version of another slide that I'm going to show you that is more detailed subsequently. But this slide kind of simplifies what ROSA, the synergy between managed AWS, our hybrid cloud environment, and ROSA, and the native API platform. It almost looks like those Russian dolls, right? One doll within another doll, and then another one in there, right? But this is the interconnectedness between those three platforms that is enabling us deliver value, integration to our ERP systems, to our internet resources, and to other on-premises applications, right? So I want you to just put a pin on this diagram and the green arrows that denote internal ExxonMobil network traffic that is destined for the API, the native API platform. That traffic is going to go through a route and through the core API namespace and to a self-hosted API gateway, part of our native API platform. And then it's going to hit the API consumer namespace that is hosted on ROSA. And from there, the traffic is going to, either egress to the internet or to other on-premises applications or to those 3 ERP systems that I mentioned earlier. This is huge. This is our secret sauce. This is the wind beneath the wings of our modernization journey. Stitching together things that are on premises with things that live in ExxonMobil resources on the public cloud and private cloud and our ERP systems. All right, so what does ROSA look like? How does our instantiation of ROSA look like, right? Bala mentioned earlier that ROSA is a turnkey application platform. So it's turnkey, right? It's delivered as infrastructure as code. You can't make a lot of customizations to it, and you shouldn't, right? You shouldn't be trying to make a lot of customizations to it because, remember, customization is actually why we're going through this effort, right? All the customizations that we built into our legacy systems is why we're trying to modernize. So, but ROSA is custom built almost. It is our own instance of ROSA is deployed is the classic topology. We deployed it across 3 availability zones. Now I mentioned this that it's classic because we're not using the hosted control plane method for ROSA deployment. There's a reason behind that. It was too new for us to assess. By the time we were deploying this, we had business cases that were ready to go. So we chose to go with the ROSA Classic deployment, which means that we host our control plane nodes within our ExxonMobil accounts. The ROSA platform that we own is built on Security Token Service, STS, which allows us to interact with the key management services that are native to AWS. We leverage the open virtual networking topology for our networking for all the namespaces within ROSA. I'm going to talk about this much more in later slides and why it's important, right? And we built ROSA, our compute nodes, the persistent volume underpinning our compute nodes, our ROSA worker nodes, is built on FSxN, the AWS File System X for NetApp. The reason we chose FSxN is because that's what we use on premises. Remember, we're trying to provide our customers who are migrating from premises to ROSA with a seamless experience, with a very uniform experience that looked like what they had on premises, right? We already know that ROSA looks and feels like OpenShift container platform on premises, which is something that we had. But we want to make sure that when those customers move, those applications move from premises to ROSA, they still get the same performance from a storage backend as was on premises. Now, I'm going to just share a little bit about why we're succeeding in our modernization effort. Part of the reason that we're succeeding is because we no longer have to manage our underlying infrastructure components. Our team doesn't have to manage our storage backends, our NetApp. We no longer have to manage our network pieces. We no longer have to patch and upgrade our network switches, right? We don't have to manage our compute platforms. So all of our hardware, we no longer have to manage that because the hyperscaler, AWS and Red Hat, have taken that responsibility away from us. And what this does is that it unlocks our centralized platform team, our container platforms team, to focus on value delivery, to focus on enabling our customers' speed to market, to focus on what I call enablement accelerators. Moving our attention higher up the stack allows us to go help our customers deliver, really. So I'm going to spend a little bit of time and talk about 2 key enablement accelerators that our journey to ROSA and to the cloud is offering us. The first one is something I call namespace management, right? This looks very interesting because many enterprises will just have one application per cluster, maybe one application to one ROSA cluster. That's not the case. Our centralized container platform is multi-tenant in nature. So we host multiple applications, multiple services on one container platform. But because we no longer have to manage the underlying pieces of our environment, it allowed our team to provide access to our backend namespace API, our backend namespace management APIs, for them to be able to unlock value. This allows our partners in the API management team to scale on demand. They're able to create namespaces autonomously using the API calls to call our backend APIs to create the namespaces. This is huge. This is really, really huge because historically, when we started container platforms at ExxonMobil, we used to have a scenario where customers would request the namespace by email or by a messaging service, right? Please, can you create a namespace for me with 4 virtual CPU cores and 20 gigabytes of RAM? And then we'd go satisfy that request, and then we email the customer back. And then we kind of modernized our practices to where it became automated. We created a form, and then expose the URL for that form to customers, and whenever they hit that URL, they will go request a namespace, 4 virtual CPU cores, 20 gig of RAM, 100 persistent volume claims, 100 gigabytes in storage, things like that. So it was really, really automated. In 5 minutes, you'll be able to create a namespace, less than 5 minutes even, from submitting a request form. However, because we're trying to reimagine our integration platform, because we're trying to build a solid foundation for the future of our compute, it was important for our customers, our partners, our API management team partners, to be able to dynamically, on demand, request a namespace per API. So we spent some time building out a process for them to be able to do that. So what we built for them still allows us to be able to track the namespaces that the API team has created, and then they're able to steward those for accountability, right? But this is a very, very big enablement accelerator. Now our partners are able to deliver value quickly without having to go through the overhead of submitting a request form. Now, why is this a big deal? It is a big deal because, as I mentioned earlier, ExxonMobil prefers centralized multi-tenant platforms, multi-tenant container platforms. Now, differentiated use cases, differentiated workloads can use native container services like EKS or ECS or something like that as they require. But our preference is that for most of our workloads that can run on a centralized platform, let's co-locate those. Let's provide security hardening one time. Let's do our risk assessments, our vulnerability assessment testing. Let's deploy our security tools like Prisma Cloud or Advanced Cluster Security that help us detect malware in container images, right? Let's deploy those once on one container platform, and then we manage those. But centralized platforms also allow a lower barrier to entry for our application teams. We want our application teams, our developers, to be able to focus on what matters most to them, which is development, security, operations of their application, not of the platform that the application is hosted on. Let them focus on building transformational applications that will transform our business in the future. There is a lower service cost component to a centralized platform because you're not replicating your minimum kit, right? Things like your control plane, your infra nodes, your master nodes, you don't replicate those across multiple instances. You just build one cluster and multiple applications use it. You're able to onboard customers seamlessly and in a streamlined fashion. If you have fewer clusters and you write your documentation for those clusters and customers just leverage them, it just makes for an easier experience. So what we did in the previous slide with enabling our customers do on-demand scaling of namespaces was non-standard. We weren't prepared to do that if we're still bogged down with managing our infrastructure on premises. I want to talk about accelerator number 2. This accelerator is actually the slide that I showed you earlier that I mentioned was our secret sauce, our golden goose, right? This is a more elaborate diagram of that slide. And I kind of broke it down into 2 slides so it's easier to digest because it's a little bit more involving. So just continuing with the diagram that we saw before, internal ExxonMobil traffic is on the left-hand side, while internet traffic from an API consumer is on the right-hand side. So I think I'm just going to illustrate on this side of the room for the left-hand side and on the other side of the room for the right-hand side. So internal ExxonMobil traffic will go through the corporate data center, and then it will transit through a transit gateway into a transit gateway attachment that you will see in the next slide. I promise you it's there. It's in the next slide. There's a transit gateway attachment that is on the next slide, which is where that traffic is going to go through, be funneled through into a ROSA cluster load balancer service that distributes the traffic to the availability zones. On the right-hand side, traffic from the internet is going to pass through a CloudFront service, which also has a web application firewall that does rudimentary packet inspection. It checks for OWASP top 10, and then just make sure that the packet is okay to be forwarded to where it's intended to go. That traffic is going to get an elastic IP address, and we're going to move to the next slide. And I'm just going to continue on with illustrating the right-hand side of the slide because I kind of described the left-hand side earlier. So the internet traffic is going to continue on through an internet gateway service into a gateway load balancer endpoint, and that gateway load balancer endpoint is going to send the traffic to a DMZ for further inspection. At the DMZ, the traffic becomes stateful. It becomes a stateful session, and then it can come back into to the gateway load balancer service, which sends the traffic back down to an external network load balancer. The external network load balancer takes the traffic into an external application load balancer service, and from there to a gateway load balancer endpoint and into a DMZ inspection again. It gets further inspected, a stateful session is created, and the traffic gets sent back out to the gateway load balancer endpoint and to the ROSA network load balancer service. From this ROSA network load balancer service, traffic gets distributed to the availability zones that we have for our ROSA platforms, and then it inbounds into, remember the API consumer namespace that I talked about earlier? It goes through a route and a self-hosted API gateway and into an API consumer namespace, and from there the traffic is distributed to where it's intended, either to our ERP platforms, those 3 that I mentioned, molecule extraction, molecule management, or centralized services. The traffic is going to egress into our ERP systems or to other applications within its ecosystem on premises or in public cloud, right? But this is it. This is a more elaborate diagram that describes how we are making sure that integration happens, how we're making sure that business-to-business communication happens for ExxonMobil, right? So up until this moment, I have talked about the case for action, right? Why we're going through a transformation exercise at ExxonMobil, a modernization exercise to build a solid foundation that underpins our delivery of digital products for the future, a streamlined digital world for our future. I've talked about what our ERP landscape look like with 10 ERP systems that are getting rationalized to 3 ERP systems and modernized at the same time to mainly cloud-based ERP systems. We journeyed and wove through some of our quick wins and how native API platform deployed on ROSA is enabling us to integrate these new ERP systems and the ecosystem of tools and applications that it needs to run. We talked about what our ROSA platform looked like, and then we talked about some of the enablement accelerators that we've been able to provide our partners within ExxonMobil. Now, I want to just go ahead and share a little bit about some of the learnings that we have garnered, we have accrued through this exercise. One of them is that, well, private link is required for SRE access, right? We don't want to manage the underlying hardware for our cloud platforms, so we need the hyperscaler to manage that for us. But how do they manage that if they can't, and also the control planes, but how do they manage that if they don't have access to our clusters? On the face of it, this looks like, well, you need to have a private link access, but within our environment, within our ExxonMobil IT environment, there were significant security and controls and risk management implications for having a dedicated network tunnel that allows access into our assets. We had to go through elevated reviews, multiple elevated reviews for this design for private link. It took us a lot of cycles to get through that, right? But the private link is existing now. It's working. Our clusters are being maintained and managed by Red Hat and AWS. But this was one of the learnings that of what we didn't have on premises. On premises, we didn't have private link, but just it took us a little bit of time to get through and work in collaboration with Red Hat and AWS to figure out compensating controls for private link service. The other thing that I want to mention is that in ROSA, customer-supplied domain names are not supported. If you've deployed a ROSA cluster, you will get a randomly assigned domain name at the end of a deployment exercise. The complication with this is that on our machines at ExxonMobil, our laptops, computers, we have a software-defined perimeter that does not allow third-party domain names like the randomly assigned domain name that you would get when you deploy ROSA. So this became a little bit of a challenge for us. We had to go through elevated reviews, and we had to work with AWS to develop a set of compensating controls before we could add that domain name to our match list domain so it could resolve within our DNS, right? But this was huge. It took a lot of cycles from us. And I think this is also an opportunity for Red Hat and AWS to consider a bring your own domain name service, right? For customers who are going to be deploying ROSA to be able to bring their own domain names. Because now our ROSA cluster looks just a little bit different than the rest of our clusters. The naming convention is different because it was pretty much randomly generated for us. So there's an opportunity for improvement there. Something else that I mentioned earlier was that we deployed ROSA on OVN, Open Virtual Networking. Well, the first instance of ROSA that we deployed was deployed on software-defined networking, SDN. But then Kubernetes was deprecating SDN pretty much, right? There was no in-place migration path to go from SDN to OVN for ROSA. So I had to go back and redeploy our ROSA platforms to OVN. Took a bit of time, took quite a bit of time for us to do that. But then one of the consequences of moving to OVN rather than SDN is that what we typically used to manage IP addresses, NAT IP addresses for our namespaces, we no longer had access to. It was no longer compatible with OVN. So the egress IP IPAM operator, which is community supported, is compatible with SDN, but not OVN, right? So this was another challenge for us. So we had to go write a homegrown script that will help us manage our IP addresses as we scale our cluster. Because we need to scale our cluster to meet the needs of our API team and also the migrations that we're doing from premises to the cloud. And also for organic growth of the cluster with net new greenfield applications. So we need more IP addresses. But how do we manage that if we no longer have egress IP IPAM operator compatible with OVN? So huge learning there. All right, so this is it. This is really it. This is how ExxonMobil is going about our modernization and transformation journey, enabled by ROSA. We have worked, collaborated internally with the ExxonMobil teams, with the ExxonMobil AWS team, our networking team, and also externally with AWS and Red Hat to build a ROSA platform, to design a custom network ingress that allows for B2B and B2C connections that allows us to achieve value. We've done significant work to build a modernized and transformed ERP system, ERP landscape. This landscape is going to allow us to streamline the way that we deliver digital products and to provide industry-leading performance in efficiency, effectiveness, and the experience of our customers and our employees. We did all this work. We spent a lot of time and a lot of energy doing this and collaborating across teams because we know that the old ways of doing work will not open new doors. Thank you.